Hi, I'm Jim from BATS Research and Training. Welcome to a sneak peek at the BAT License Training Program. This is the third video in the series, so if you haven't seen numbers 1 and 2, I would suggest you might want to go back and have a look at those, because these kind of set the scene, I guess, for what we're going to be talking about here. In the first couple of videos, we cover units 1 and 2. So unit 1 is legislation, licensing and planning, and unit 2 is considerations for BAT surveys. And I say in those videos about how they're nobody's favorite topic. Nobody gets into BATs because they're really fond about the legislation. But clearly, we need to understand the legislation because it lays the groundwork for all that we do. In a similar way, consideration for BAT surveys also kind of lays the groundwork for why we undertake surveys in the first place. Moving on to Unit 3, we get to ecological considerations for BAT surveys, also known as BAT biology and ecology, essentially. And this is such a large topic that it's split over 2-day sessions. And we cover a huge range of topics. So we start off by talking about energy. So energy drives all life on Earth. So it's crucial to understand how these animals get energy and how they use energy. And understanding that will help us understand the species better, will help us survey for them better, and then fundamentally plan better compensation and mitigation, etc. So we talk about the range of things that bats use energy for. So in the slide here, you can see flight and echolocation. So flight is one of the most energy demanding things that bats do, but clearly they need to be able to fly to get around and feed and take on food in the first place. When young are born, they're very small, and they clearly need to grow up to be fully functioning adults. So there's an energy cost associated with that growth, but also maintenance and storage as well. Leading into young being born, of course, bats have to mate. So there's a short clip here of a nocturnal bat singing from a mating roost, slightly blurry because it's taken from one of our trail cameras. We'll come back to this little fella a little bit later on. And then we talk about one of the strategies bats have for kind of managing energy use throughout the year, and that's maintaining body temperature or not maintaining body temperature. Humans, we maintain a set body temperature all the time, whereas bats are able to fluctuate this and allow their body temperature to kind of drop to the ambient temperature. And in doing so, able to kind of save energy. And this happens on perhaps a daily basis, maybe through summer months, but also kind of a longer term basis when we think about the hibernation period over the winter. I said we come back to this nocturnal bat, and we can see him here recorded on the trail camera, rubbing the glands around his neck, so kind of scent marking outside of his roost. And this is a mating roost, as I mentioned earlier on, designed to attract females in. And this is an approach known as resource defense polygamy. So where a male bat holds a territory and then aims to call female bats in. So let's find out if he's successful. So we can see another video here of him singing. And there we go. Success. At least one female bat joining him in his mating roost. So we talk about the different mating strategies. And I've mentioned this one already, the concept of males holding a territory and then calling females in. So we talk about the range of different species that use this approach. So the horseshoes use it. Obviously, they would need to do it in a building, whereas in trees, we have other species such as the nocturnal bat there was Lysa's bats, but we also see pipistrelle bats using this approach as well. So understanding the different mating strategies is really key to kind of understanding the ecologies of these different species, because it will affect how we plan and how we undertake surveys for them. Certainly as we get towards the latter part of the year, when we know that bats are undertaking kind of this mating process. So if we were to try to survey, for example, trees where you may have had Bechstein's bats earlier in the year, it's unlikely that they're going to be there because they're going to be going to more sites like this, these underground sites where we know they hibernate. And before they hibernate, they undertake this process we know as autumn swarming. And it's so predictable, and the bats arrive in such great numbers there that we can predict it and we can catch bats for study. We talk about what a bat roost is. And we kind of go into this in some detail. So we kind of kick off generally just trying to think about what a bat roost is, what bats require from their roosts. And this is an important part of understanding bats. We know that we will be going out, we'll be surveying either structures, buildings like this, maybe bridges, etc. for bats, but also things like trees as well. So understanding what bats require from a roost site is really important. I mentioned earlier on about how if we were surveying for Bechstein's bats towards the end of the year when they start mating, probably unlikely to find them in a tree because their mating strategy is promiscuity. So they go to these sites where they hibernate and mate there. So we have an exercise where I get trainees to compare and contrast two different species. So we've got nocturnal bat and Bechstein's bats here. And on the face of it, they're fairly similar. They both like trees. They both like woodpecker holes in particular in trees. And so we know that the summer roosts are going to be pretty much in trees with a large proportion of them being woodpecker holes. But we also know there's some differences. So I've mentioned this kind of difference in mating. So with the nocturnal bat, they set up these territories and the males call the females in. We saw the videos earlier on, whereas with the Bechstein's bats, they mate by promiscuity. So they go to their hibernation sites and they will mate there. And one of the key differences, despite these species both being heavily reliant on trees, one of the key differences is where you find the bats in the winter. And so our nocturnal bats, you'd expect them to see in the trees throughout the winter because they've set their territory up, they've advertised, they've called the females in, and clearly they want to defend that. Whereas with Bechstein's bats, they've gone to a different location. So they've gone to these underground sites where the females will be hibernating, they've mated there, and then why come back to the summer sites and roost in trees? No, they hibernate underground. And there are no records on the bat tree habitat key, so far at least, to suggest that Bechstein's bats hibernate in trees. We also talked about some of the other differences in these species. So I've got two videos here taken from endoscopes. And the first one here is of Bechstein's bats in a woodpecker hole. And you can see they're roosting below the entrance there. But if you look at how they're roosting, they're kind of tucked away. They're almost camouflaged. They're trying to just kind of get out of the way, and their skin, the tail membranes, really camouflages them nicely against the substrate of the woodpecker hole. With this one, we have nocturnal bats, and again, in a woodpecker hole below the entrance, but the way they're positioned is slightly different. That they're actually kind of sat there looking back up. And this is typical of what I find in trees for nocturnal bats, at least, is that they're big bats. They can defend themselves. They kind of, you put an endoscope in the tree and they're just looking at you going, yeah, so what? Increasingly, we know the kind of the difficulties we face around surveying bats, in particular when we're thinking about roost surveys or emergent surveys, that as it gets dark, our eyes just don't function as well. But we know we have a range of species that emerge much later on. And we have some interim guidance out at the moment, which talks about the use of night vision aids. And this is gradually being kind of brought in over the next few years and will become a requirement at some point. So we talk about the kind of different setups that are available. So we've got some fairly basic ones here. So kind of just a camcorder with an infrared setting coupled with some form of infrared light. So you might have a kind of floodlight like on the left, or kind of a torch, which is used generally for hunting. So the amount of light, the spread of light is variable depending on the kind of purpose that it was built for. Or you have slightly more advanced setup. So here is a CCTV setup, and in the background you can kind of see the light, the purple lights, and all of those are cameras, and they feed back to one laptop, and you can see the 4 different videos being fed into that one location there. So slightly more advanced setups, and I'm sure we'll see more and more of this as it becomes a requirement. One of the assignments that I set in this unit is what I call species profiles. So we have 17 or 18 different species, depending on which authority you believe, and they're all slightly different, because if they weren't different, they wouldn't be different species. And so I encourage my trainees to get to know the individual species better, because if we know the individual species better, we will be able to plan better surveys. If we plan better surveys, we get better results, better data. If we have better data, that then ultimately leads on to better mitigation and compensation, which is kind of the end point and why we're all in this situation and why we're all in consultancy at the end of the day. for conservation. And so here at the beginning of the second session, I mentioned how this is such a large unit, it's split over 2 sessions. I asked trainees to go away and research just one species and then come back and speak about it for a couple of minutes during the beginning of the second session. So here's one of the trainees talking about Brandt's bat. So she's put together kind of a range of photos and diagrams and things on the Jamboard, and you can see various things to do with its distribution. You can see various things to do with identification there, a bit about roosts and echolocation calls and food and prey as well. One of the key elements that allow bats to be successful and to get about, we talked earlier on about flight and echolocation. And so we talk about the importance of wing design. And the shape of the wings tells you a great deal about the ecology of different bat species. And it links all of these things on the screen here. So the echolocation calls that they produce, the hunting style, the prey species that they feed upon, the habitat they forage within, and their kind of relative mobility or potential for migration, so how far they can fly. And so we talk about the importance of wing designs and the kind of various different variables that bats have evolved over millennia to allow them to take advantage of different situations. And so there's various different ways we can go about thinking about wing design. So one of them is known as aspect ratio. There's various different ways we can calculate this, but in its simplest form, it's the length of the wing compared to the breadth of the wing. So here we've got quite a broad wing. We can think about wing loading, so that considers the weight of the bat divided by the total surface area, as indicated here on this slide. But we can also think about things like the curvature of the leading edge of the wing. So we know that bats' wings are made up of elongated palm and finger bones. And because of this kind of setup, we get kind of reasonable variation within our bats. So these are all Myotis bats. They're all closely related. Top left is Natteras, top right is Bechsteins, bottom left is Daubenton's, bottom right is Whiskered. And if you look at the curvature from the 5th finger onwards, so hopefully my mouse will turn up on this. So where the thumb is, this leading out along the finger bones, kind of with the leading edge of the wing here. So with the Natteras and with the Bechsteins over here, we see this kind of curvature of the wing tip. And this is an adaptation to slow hovering flight. Whereas if we look down at the Daubentons in particular, it's a very straight leading edge, which is indicative by more open kind of flight species. And of course, I mentioned on one of the previous slides about wing shape affecting various things, including the prey that a species will feed upon. So it's not just wing design, of course, there will be a range of things that feed into that. So we talk about those, so things like habitat preferences, foraging style, even the frequency of the echolocation call will have an impact on the prey the bats will take. And this kind of links us back to where we started with this sneak peek of thinking about the energy, the requirement for energy, and thinking about how bats use that and make it last throughout the year, especially over those leaner winter months when food is scarcely or not available at all. And bats go about feeding in different ways. So I've mentioned this already, and one of the tasks I provide our trainees or ask my trainees to complete is thinking about different hunting styles or hunting strategies. So here we can see a Jamboard that was used for this exercise. And so the strategy in the blue at the top is perch hunting. So I asked trainees to come up with kind of the range of adaptations that allow bats to hunt using this style. And that can include kind of morphological characteristics, so things like wing shape, maybe kind of weight of the bat, but also things like the design of the echolocation call as well. And I asked trainees to think about an example bat species that uses these strategies. So here we have perch hunting, which is one that's favored by the horseshoe bats in particular. So you can see the trainees have dropped a load of information on the Jamboard, and we're having a bit of discussion, a bit of feedback about this hunting style from the trainees. And I've talked about how we have a range of different species, and they're all different because if they weren't different species, sorry, if they weren't different, they wouldn't be different species. And one of the way they differ is this, obviously, the hunting styles, and there's various different kind of hunting adaptations that we see in our bats. And these adaptations are quite often the features that we use to identify bats. So in the top row, we've got two Myotis bats again. Top left is Natterer's bat with the S-shaped calcar and the row of stiff bristles along the edge of the tail membrane. If we compare that to the top right, we have our Dahl Benton's bats, and it has a very long, straight calcar, but large, hairy feet, which are designed for foraging over water, of course. And in the bottom, we've got different ear designs with the brown long ear at the bottom left and a nocturnal bat in the bottom right, almost the kind of two extremes, I guess, of how big relative to the body the ears can get, or how small relative to the body the ears can get. And clearly, these are adapted to the different approaches that these species use. And ear design is clearly very closely linked to echolocation call design as well. So we have a bit of a chat about not only the morphological, the physical attributes of the bats and how that means they're adapted to a particular way of foraging, but also how their echolocation calls will impact how they forage as well, and the kind of relative pros and cons of the different designs. So that includes things such as the frequency of calls that are used, maybe the duration of calls, the interval, whether they're constant frequency, quasi-constant frequency, frequency modulated, all of these various kind of parameters, or like in the video here with a kind of nocturnal bat, whether they use harmonics. It's these kind of repetitions of the base frequency here, whether they use that as part of their echolocation call design. So that's it. Bit of a sneak peek at sessions 3 and 4, unit 3, ecological considerations for bat surveys. Hopefully that's been interesting and useful. I will put up a new video next month after we do the next session. And next session will be covering a range of topics. So we're going to talk about preliminary ecological appraisals. We're going to talk about preliminary roost assessments, so building inspections essentially. And we're going to talk a little bit about report writing. So I might see you then.